Hey everyone, welcome back to Code Streak Daily. In today's video, we are going to solve the Leetcode's streak problem. We have the title maximum number of moves in a grid. So here we are given an zero indexed m cross n matrix grid consisting of positive integers only. You can start at any cell in the first column of the matrix and traverse the grid in the following way. From a cell row column, you can move to the any of the cell row minus 1 and column plus 1 or row column plus 1 and row plus 1 column plus 1 such that value of the cell you move to should be strictly bigger than the value of the current cell. Okay, return the maximum number of moves that you can perform. So here we have a 4 cross 4 matrix, and in the first row we have the elements 2 4 3 5, and second row 5 4 9 3, third row 3 4 2 11, and fourth row 10 9 39 15. So the output is 3. We can start at the cell 0 0, that means in the first cell which is having the value 2, and make the following moves. From 0 0 we are going to move to 0 1, so that the value of current cell 2 is greater than less than the next cell 4, so we can make a move. And then from 0 1 we can make a move to 1 2, that is 9, because we can't move this side as we are having the value less than the current cell, so we are moving to 9. And then from 1 to 1 2 we are going to 2 3, because it is having the 11. It can be shown that it is the maximum number of moves that can be made. Okay, so in the second example we have a 3 cross 3 grid, and starting at 0 0 we cannot make a move to any of the cell because the values in the its adjacent cells are less than the current cell value, so we cannot perform any move, so therefore the output is 0. Okay, so now let's break down the approach, how we will tackle this problem. We'll see. So we have to set up some directions for moving right. Okay, we'll use three possible directions to move from any cell, that is top right, right, and bottom right. Next we're gonna have a DFS with memoization, that from each cell we'll use a DFS to try moving in each of these directions, but only if the destination cell has a strictly greater value than the current cell. Okay, to avoid redundant calculations we'll use a memoization to store the maximum moves we can make starting from each cell. Next, we have to loop through first column. Since we can start from any cell in the first column, we will initiate DFS from each of these cells, keeping track of the maximum moves we find. Okay. Now let's start coding. Here we have a class solution, and we have function defined max moves with a grid passed, and we have to return an integer. Okay. Now I'm gonna import list from typing import list. Okay. Then we have a function defined. Now we have to grab the number of rows m and column n of our grid. Okay, then we'll define our directions for moving to the right, that is as I said, top right, right, and bottom right. Lastly, we'll initialize a memo as dictionary, which will store the maximum moves from each cell, so we don't recalculate values unnecessarily. Okay, so mn equals to 1, we have to get the length of the grid, and length of grid 0, we get the rows and columns. Next, I'm taking variable directions equals to, as I said, we are going to move top right minus 1 and 1. Next right, that is 0 and 1, sorry, 0 and 1. Next we are going to move bottom right, right, 1 comma 1. So these are the directions defined. Next I'm taking memo, a dictionary. Okay, now here we are going to write a DFS function. So def DFS, which has rows and column as parameter. Okay, row and column. We have to check if row column is in memo. In that case, we got to return memo of row and column. Okay, so we are checking the memoization. If we have already computed the maximum moves from row and column, we'll simply return it from row and column itself. Okay, next I'm going to initialize a variable max moves to 0. Okay, for each direction we calculate the new position. I'm gonna take variables new row and new column. If this position is within the grid bounds and the value is greater than the current cell, we recursively call DFS and update the maximum moves if we get a higher value. Okay, for that we need a loop, right? For dr and dc in directions. So we take new row, new column equals to row plus dr and col plus dc. Okay, now we have to check if 0 less than equals to new row less than m and 0 less than equals to new column less than n and grid of new row, new column is greater than grid of row and column. In this case, what do you have to check? Max moves equals to max of max moves and 1 plus we're gonna recursively call the DFS with new row and new column. Okay, next we have to make a update in the memo, right? Memo of row and column is equals to max moves and we are going to return max moves for the function DFS. Okay, after checking in all the directions, we store max moves in memo to avoid redoing these calculations. This gives us the maximum moves from any cell in constant time, right? After the first calculation. Now we have to, okay, we also need not do this in the if condition. Okay, I'm just returning it. Now we have to take another variable max total moves and initialize it to 0. Now we are going to loop through each cell in the first column, calling DFS on it to see how many moves we can make from that starting point. Then finally we will return the max total moves, which is the maximum moves from any starting position in the first column. Okay, for row in range of m, max total moves equals to max of max total moves and DFS of row and column 0. Okay, now what we are going to return? Return max total moves. Okay, now let's run the code and check. Okay, cannot access local variable max moves where it is not associated with the value. Okay, where we are getting this error? Memo. Okay, in that case, this should be inside the if condition only. I guess. Wait, give me a second, guys. Let me analyze this. Yeah, here I made a mistake. Wait. This has to be outside the condition, outside the if, right? So we just need to hit a backspace for everything. Okay, now I guess it's fine. Now let's run it. Yeah, our code is accepted. Let me submit the code and check. Yes, as you can see here, our code is working fine. We have a runtime of 187 milliseconds and it beats 42.42% of users, not even half. Okay, when compared to yesterday, the user beat is still less, but it's okay. We can give a comeback again, and this is how we have solved this problem. And coming to the time complexity, we have a time complexity of order of m cross n only, and the space complexity is also order of m cross n, uh, because we are using a memoization technique. Okay, this solution is efficient, I guess. And if you like this explanation helpful, please do hit the like button and do share this video, and also subscribe to CodeStreak Daily for daily coding problems on Leetcode and also on Geek for Geeks. And if you have any questions or suggestions, please do put that in the comments of this video. And if you have more efficient code than this, please do put that in the comments. I'll surely check on that. See you in the next video, guys. Until then, keep streaking.